So Isaiah Berlin is a intellectual historian, by which I mean he's not a historian who's an intellectual, although he is, that he is a historian of ideas, a historian of the Enlightenment, of politics, and he's got a very broad range of publications. But I think what makes him particularly insightful on the idea of scientific history is sort of his background in David Hume and empiricism and the idea of how do we know things are true and how do we explain the universe sort of around us. And Berlin is very much contemplating in 1960 this idea of scientific history, which has been going on for 150 years at this point, something that has come out of the Enlightenment, not necessarily part of it. And I'm interested in your perspective as well. For me, it seems that he understands the impulse behind scientific history, but he's dubious or suspicious about the idea of how effective it is or whether it's the right practice for historians. And as somebody who's coming at it from a different perspective, what is your impression of scientific history? What did you think scientific history was trying to achieve?
So it's a really good question, because I wasn't surprised when I realized somebody has been trying to do this. We've studied history in high school. We've studied we've studied more science as I became an undergraduate student and as a postgrad. But when I first came up about the idea, I was like, yeah, I've thought about this before. Why not we can model humans, how they're going to be behaving in the future, model also of systems like these, more like social systems. So scientific history tries to use the success of science, let's say, the fact that we achieved so much success using this scientific method to try and apply it to history, or make a scientific subject out of history to try and predict events in the future, let's say revolutions or wars, or we could use it to predict crises, financial crisis, or and so on and so forth. But it makes sense to anybody it comes naturally that I think if you seen all the success in science in predicting events in the future, like an explosion of a star after a certain amount of years. Today we could quantify the age of our star. So not just predicting, also retrodicting. So these days we could actually retrodict what happened before we lived in, let's say, after the Big Bang, or what happened a fraction of a second after the Big Bang, or and we could predict what's going to happen to the universe later, and millions of years or billions of years, and so on. So people thought, okay, if we can predict how the universe is going to behave, or if we could retrodict how the universe. So retrodicting is predicting things that have happened in the past without observing it. If we could do that in the universe, why not we could do that in history? So history is to do with I think our humans' sort of activities, and what happened to humans in the past, and what humans have done in the past. So why not we could predict history and retrodict history. So that's what I think the scientific history is trying to do, using the scientific methods, this engine that drives science to, because that's what science is good at, predicting, to try and also make sense and predict, or make models, let's say, of the history, to try and reach a new basically, or predict the future, or retrodict parts of the past, or fill parts of the missing gaps in history, let's say.
Yeah, and I think you said several times in there the success of science in doing these things, and this is something that Berlin really explicitly says on page 2. He says that it's natural to wish to apply the method successful and authoritative in one sphere to another, where there is far less agreement among specialists. And I think this is the the key aspect for scientific history for me, is this idea that scientists, because they're dealing with facts, because they're dealing with mathematics, they agree that there is one correct answer to any given question, whereas historians tend to fight a lot and they don't give a lot of ground, and they come to completely different interpretations and conclusions, and they can't prove one way or another. And I don't think that Berlin sees it as that cut and dry between science and the humanities, but that's certainly the impression I got growing up, going through school, is that, science was fact and history was interpretation, and I think there's much more of an overlap and a middle ground between these two. And for me, I think that's what scientific history perhaps should have been trying to do. It should have been trying to um, narrow the band of interpretation, make it so we have more common ground on what we were talking about. Um, but I personally don't believe that we are able to come up with the one correct, complete, every variable accounted for definition of what happened in the past. And I don't know if we're even able to do that in most sciences, to be honest. But um, I do think that that's what the 19th century scientific historians were trying to do. I think they were ambitious in that they were going to figure out all the variables, and they were going to figure out exactly what had happened in every detail. And I think that's what Berlin is concerned about, is this idea of taking it too far. Um,
That, yes, it does come natural that when something successful works in science, you want to apply it to history. But that also works as well in between subdisciplines of science, like between physics or biology. We try and collaborate, mixing subjects together. Let's say when we come up with some solution for for some physical solutions about, let's say, how materials bind with each other, we go to a biologist. Let's say, oh look, we have come up with a way in which materials bind to each other. We might be able to use that to bind some medicine to some viruses or some bacteria, and that helps you improve. So we tend to use this collaborative method to try and develop different parts and mix the subjects together of and develop different parts of science.
so the next thing I kind of wanted to ask your opinion on is this idea that we can have the variables. So when you're dealing with theories in your own work, your own personal work, how broad are they? So are you dealing with very specific theories about a small number of variables that you can kind of be relatively sure of or control, or are these theories that you're working with sort of general principles of the universe?
Yeah. So in science, um, when we make a model of, let's say, the solar system, we, especially, let's say, we make a model about how okay, so let's go back to the solar system. Has got the sun, which has got huge mass, and it's got these planets around it with smaller masses, and they're evolving. If you were trying to predict where these masses gonna, so when these planets gonna be after 6 months, we try and forget about everything except a small number of parameters. We're trying to predict. So we put inputs that are the masses, the separation of these planets from the sun, and some other small input, some other number of inputs. But these are the main ones. But we don't try and put so many complicated variables to only predict the revolution of these planets around the sun. We don't care too much about how hot is the sun, let's say, or we don't care too much about whether these other planets have got life on them, or whether these planets. All we care about is how heavy these masses are, because that's what the theory needs from us. Theory of gravity needs the masses, needs the separation, and it will give us a force which will be able, and sorry, the speed as well, and that will give us the location of these planets later. Um, I think that's one of the makes what makes science so different from, or pure natural sciences, let's say, so different from what scientific historians are trying to do. Uh, they Because in science you could reduce the whole problem, the system, into a small set of number of variables, and we could quantify these variables. We could use numbers, as I said, like the masses in kilograms or separation in meters. We can actually come up with a conclusion. When we go to history, uh, things are much more complicated than this. We find that there's, so one of the sort of ambitions. So that's why it was ambitious for scientific historians is that they thought that we could reduce, let's say, a revolution. Let's say the French Revolution. We could reduce it to X number of people, um, and maybe some their economical status, and that number of people and their economical status, and how those people fought those people. It's But it turned out that this is not as simple as it looks. So a revolution doesn't happen just because you could reduce the number of people to X and their economy to Y and then solve some equation. Um, there are so many factors that are to do with us humans and our behavior, because history is to do with us and our activity and our what we do basically on day to day basis. But our activity is not only to do with economy. It's to do with our economy. It's to do with our need for our physiological needs, like let's say food or shelter or procreation or family or social life and so on. And then we realize very soon that there's so many variables that we could model, and each one of these objects or variables is actually interconnected with each other. There's a huge network of of variable in one human, and if we have 20 million humans, we have a huge network of different variables that we can't use all these inputs. We can't quantify even all these inputs to come up with a solution or an answer about whether a revolution will happen. That we could go back to politicians or policymakers and tell them and inform them to make a good decision that will uh, inform the future. Or let's say a war is going to happen, and then we go to the politicians and then say, look, you should do something to stop this war from happening. It turned out that it's much more complicated, and and that's what makes physics, especially physics or mathematics, so different from history or from scientific history or sociology. So as you go from um, physics down to biology, down to psychology, or maybe um, yeah, psychology, and then sociology, and history, uh, our quantifications become so poor, our predictions become very inaccurate, and that's the difference that has been. It's good that I'm we're mentioning physics, because physics is so contrasted from his history. But as we go down this path of toward psychology or toward that's why psychology itself is actually a mixture of so many complicated concepts, um, and we use it to predict what's going to happen to a human later. Um, so yeah, I think uh, that's the difference, and that's one of the things that scientific historians were trying to reach, is abstraction of concepts, using the success of science to try and predict events.
It's really interesting to listen to you speak about that, this idea of abstraction. And you said something really analogous there, where you said that if you were looking at the masses and the circular velocity or what have you of the planets orbiting the sun, you didn't care about how hot the particular star was, that wasn't relevant to that particular question you were asking. And that seems really analogous to me. So you get historians who say, well, I know that the French Revolution had economic, social, political, psychological, personal politics kind of aspects, but I'm only going to look at this one aspect. I'm only going to look at, you know, gender relations in the aristocracy, because that's my little thing. So I don't care about the economy or anything like that. I just want to do this one little bit. Um, And that is something I feel historians have a lot of reservations about. Anytime somebody tries to say, well, I can't speak about all the variables because there's too many, so I'm just going to look at this one aspect, everyone gets very nervous and they're like, well, yeah, that's true, but it doesn't help us unless you look at everything all at once. So I feel like historians have to abstract because we have too many variables, but we try to abstract in a really broad ad hoc way with every situation, which are the 17 variables in this particular case that I think are most important, as opposed to my understanding of something like physics, where there's much more of a consensus about a given type of problem, which variables are going to be most relevant. And it seems to be more transferable from instance to instance, as opposed to in human past, where everyone seems to think that each event is such a different combination of those variables that we can't use the same formula over and over again. And I don't know, is that sort of how you feel about it? The reason that you're able to abstract to just a smaller number of variables is because there is some kind of homogeneity between instances.
Yeah, so I think that's what Isaiah Berlin was mentioning as well. He was so there's no we don't have any problems with studying. Let's say, I mean, okay, as far as I understand, maybe you could reach some basic conclusions about, let's say, influence of the French Revolution on gender, let's say, or gender equality. Um, but that's what so what was I Berlin is trying to mention is that we in physics, let's say, when we say a conclusion, when we come up with a conclusion, the conclusion is a direct and consequence and the only consequence that has happened due to these inputs. So we know very well that okay, so let's say if we use the theory of gravity, we know that the position of these planets after 6 months are only due to their masses, due to their speeds, or due to the separation from the sun. Uh, and that's what we have problems. So in history, we have problems with historians using, especially terms like therefore, as a result,
Yeah.
in conclusion. Their conclusions become much more vague, much less direct to the premises compared to what we're used to in physics. Um, they historians do that, and that's fine in history. But when it comes to trying to apply science into history, then we as scientists we have problems with using these terms, especially these terms, because your conclusion is never so um, so separate from everything else except your premises, and that's what makes this project much more ambitious than because in science we try to reduce everything to small concepts, while in history there's such a complicated network of variables that we never can resolve everyone and separate them from each other.
And I think that's something I really wanted to ask your opinion on. There's a point in Berlin's article where he says where he refers to the idea of falsification and the idea that in the sciences, if you are looking at a a set of occurrences, a process, and you get a different result than is expected by the model. If it doesn't work, let's put it quite bluntly, then that is falsification. That is evidence that the model is incorrect. The model breaks. It doesn't give you the results that you want. And in history, he argues that falsification isn't accepted amongst historians. So if a historian says, oh, the model didn't work, the historian's first instinct is to say, well, you looked at it wrong. You didn't get the right evidence. We know that this is sort of how humans behave. The example he gives I thought was great, which is if someone came and said that, the sun didn't rise today, everyone would be like, no, you just were looking in the wrong direction, or it was really cloudy or something, the sun rises. And for me, I thought that was great because in a way he was painting historians as being much more dogmatic towards models than the scientists, that the historians were far less likely to concede that their general cultural idea of how humans work was wrong. They're perfectly happy to argue about the specifics, but the general model of how people behave seemed to be something that historians were far more hesitant to be open-minded about. And that is sort of a reversal of everything else that's kind of been argued in the article. And I sort of wondered how dogmatic you feel falsification would be in your own particular research. If you had a model that you had been taught since undergraduates, and that if I did this, this should occur with my chemical reaction, and it didn't occur in a particular instance, how would you react to it? How does a scientist react to deviance?
Yeah. So and falsification. So okay. So in science, we try and use observations as our sort of method of telling whether our approach toward telling whether this is true or not. It's uh, if we if our observation was itself wrong, then we will get different conclusions. However, if we have tested it multiple and multiple and multiple times and took into account everything, then if our observation is different from the predicted theory, then we don't say we've falsified it immediately. We have a new hypothesis. We develop a new hypothesis. Um, but according to Karl Popper, for example, falsification is the way in which you progress science. We didn't progress from Newton's theories to Einstein theories if we weren't able to falsify Newton's theories via observations. So yes, Einstein came up with new theories about how planets behave and how planets attract each other, but uh, in we couldn't falsify Newton's theory until we actually made an experiment or observed that this is exactly how Einstein predicted. Um, in scientific history, observations are mainly made on the history. So, and that's what makes scientific history difficult as well. Is while in science we can observe phenomena, and at the same time we could repeat it in the lab by experiments.
Right.
In science, sorry, in history, we can't make experiments. We
Not
only have,
ethically.
not ethically, we can't say um, if we have 20 million people, let's say, if we want to repeat the French Revolution, and if we have 20 million people, and let's say we manage to somehow resolve everything into numbers and formula, then we still can't repeat the French Revolution to be able to make sure that this is or verify the results that we achieve from history. So our main observation through history is looking at past events. Is that's how we observe history. And some people try and make similarity between history and astronomy. So astronomy is about observations, unlike let's say biology, or unlike let's say other fields of science or other areas of science that we could repeat in the lab. Let's say the movement of electrons. If we say that electrons are behave as a wave, we could actually make an experiment to predict whether electrons will behave as a wave. We pass them through. Um, we call it the slit experiment. We pass the electrons through small openings, and then we see if they interfere with each other, and then give us an interference pattern. Because um, only waves gives interference essentially. If we see interference, we say, oh, maybe electrons are waves. Or if we see other aspects, we say they're particles. It would turn out that they're essentially both particles and waves. But and the point is that we can do that in the lab. If we come up with a hypothesis, we can actually do it in the lab or do the experiments. In science, we can't. Astronomy, we don't always do in the lab, but astronomy is based on also our understanding of physics. We can reduce everything into small sets of parameters and rely on our observation to the sky, and then we could come up with conclusions essentially. Um, so that's what contrasts science in terms of making observations compared to history, I think.